Imagine for a moment the year is 1998. You wake up to headlines screaming about an asteroid, 1997 XF11, a looming celestial threat, potentially on a collision course with Earth in October of 2028. Calculations, later proven flawed, suggested this half-mile-wide rock could devastate our planet. The media, understandably, went into a frenzy, igniting a wave of fear that humanity might indeed have an expiration date. For a few anxious days, the world held its breath. Then, just as quickly, the experts reassured everyone. The chances of 1997 XF11 threatening Earth were, in fact, near zero. A collective sigh of relief swept across the globe. Yet, the seed of an idea had been firmly planted. That very summer, two blockbuster movies, Deep Impact and Armageddon, captivated audiences with dramatic tales of world-killing asteroids. The cinematic spectacles served as a vivid echo of the real-life scare, reminding us that such cosmic encounters, however remote, were a terrifying possibility. This profound moment of public anxiety and cinematic imagination wasn't lost on policymakers. The U.S. Congress, keenly aware of the implications, turned to NASA that same year with a clear directive: detect and catalog our solar system's near-Earth objects, or NEOs. These are defined as comets and asteroids that come within 30 million miles, or about 50 million kilometers, of Earth, a distance roughly 126 times greater than that between us and the Moon. From this pivotal moment, the Near-Earth Objects Observation Program was established, later evolving into the Center for Near-Earth Object Studies, or CNEOS. This initiative, working in concert with agencies, observatories, and tracking stations across the globe, began the monumental task of scanning the heavens. And their efforts have yielded significant results. As of October 2020, they had discovered 888 globally catastrophic NEO-asteroids, those the size of asteroid 2001 FO32 or even larger. This represents a remarkable achievement, accounting for about 96% of the estimated NEO-asteroids of that immense scale in our solar system. For these largest, most devastating threats, we now have a surprisingly good handle on their whereabouts. However, the universe holds its secrets close, and a significant challenge remains. While we've made excellent progress with the largest objects, a vast and silent majority of potentially deadly asteroids still elude us. These are the thousands of regionally catastrophic NEO-asteroids, about the size of a football field or greater. Unfortunately, because they are smaller and inherently harder to find, only an estimated 20 to 30% of them have been located and tracked. Consider the potential impact of these lesser-known objects. An asteroid of this size, if it were to strike, would unleash a ground-level explosion measuring in the gigaton range. Such an event would flatten an entire city, potentially claiming millions of lives. The sobering truth is that we currently have no idea where the majority of these deadly space chunks are located. They are, quite literally, flying under our radar. Given this reality, NASA decided that some NEO-asteroids required even more focused attention. They designated a special category, potentially hazardous asteroids, or PHA. These are asteroids that are at least 140 meters in size and, crucially, miss the Earth by a mere 5 million miles, or 8 million kilometers, a distance roughly 21 times that between us and the Moon. As of January 2021, 2,160 PHAs have been detected. While this sounds like a considerable number, it actually represents only about 9% of the estimated 25,000 NEOs out there. Almost all of these PHAs belong to a group known as Apollo-class asteroids, characterized by their orbital paths that cross Earth. Among these PHAs, approximately 150, or about 7%, are global devastators, similar in scale to asteroid 2001 FO32, capable of widespread destruction. Our journey to understand and safeguard our planet from these celestial wanderers is an ongoing one. We've come a long way since the anxieties of 1998, developing sophisticated programs and making incredible discoveries. Yet, the vast, silent majority of smaller, regionally catastrophic asteroids remain largely unmapped. It's a powerful reminder of the delicate balance of our existence in a dynamic cosmos, and the persistent human drive to peer into the darkness, seeking to understand and protect. What are your thoughts on these undiscovered space objects? Do you find reassurance in the progress we've made, or concern about the challenges that still lie ahead? Share your perspective in the comments below.